Good afternoon, Professor and everyone. My name is Seyha. I come from Mobile Computing and Networking Lab in the Department of the Software Convergence in Southern University, and who is the under supervision Professor Kim Seok-hwan. And today, I would like to present about namely Federated Logistic Regression for the reliable prediction model in privacy preserving healthcare network. So, in this topic also illustrate with the federated learning logistic regression for the predict the our model to reliable prediction and the loss communication, which is the involved with the confluence of the federated learning, cloud edge computing, and for the softwareization networking architectures to predict our algorithm, which is used with the logistic regression. And this proposes also the contributions of the federated learning to modification of the federated learning logistic regression to propose enhance the reliable of the real-time communication in resource efficiency. So we will go through to our content. For our content, we have four content. We will find out the performance of the key enabling of IoT thing is the Internet of Healthcare thing. We will find out the deployment strategies of the federated learning and for the data execution, and we will talk about the reason and how can we use it with the federated learning, and what is the drawback of the obstacle with the currently in healthcare data, and how can we tackle the problem and problem solving in nowadays, and to got the optimally with the data analysis. And the last one we will perform with the data collection analysis with the method. So, as we know, the healthcare data is very content of the information which is on the such as the characteristic of diagnostic, the parameter of the patient, and one more is the model selection of the distribution and the enhanced privacy reliable in data processing. So in terms of data processing, we will have 4 points to contribution to ensure that our data and the performance metric will be better. So the first one is the communication and the computation resource, the client selection, the model aggregation, and the offloading strategy. For in order to perform the efficiency, the real-time performance metric, the computation are the very stringent for the handling in the computation and the handling in the predictions of our model, which is the have to ensure the communication between end-to-end device. So among of the data collection of in communication, there are many functionalities of data, and such as the device, the sensing, data gathering, sensor carrying. So among of them, they have a different type of the function. So it will be increase the delay or the communication perspective. So we have to ensure that our communication will be handled on the message of a heterogeneous device. Based on that, we will deploy with the computation resource, such as the processing of the flow, that will be the 3 primaries of entity that consider on the first one is on device computing capability, the second is the cloud edge assist with the resource, and the last one is the reliabilities of the interaction between central parameter. So among of them, we will find out the flow of the contribution. That the main of contribution we have three. So the first is the main data privacy and security liable on the responsibilities, which is the healthcare that we use for the data confidential for avoid just with the data healthcare and to prevent the data privacy. So in order to perform on that, we will perform with the federated learning to predict and to make the communication round in our local model. It just send the model to the aggregator. And the second is about the window congestion. For the window congestion, we will consider if the involved to loss delay and high liable for the mission critical of the patient data. And so in this figure, it is also present the distributed edge cloud for the federated for ensure the enhanced reliable for the service, the complementary function for the resource awareness. And one more thing, it is such as the MDC, this means the micro data center or wireless access point that is highly essential for the local environment. And furthermore, the correlations of the applied with the federated learning for the healthcare network have been investigated in several studies, such as the real-time medical data processing or brain thermal segmentation. So, and one more thing, it is the local model that has consists the several, such as the monitoring, fitness device that apply with machine learning to perform in our local model, and it is the access point that is connected from local model to the X server or cloud server to perform the model. So in here that we propose the system architecture which is used with the federated learning, and that we have the three primary steps, such as the collaborative system architecture, global model distribution, and the local model computation. For the upper proposed in subsection, in here the federated logistic regression system, the architecture for the healthcare system, to expression the collaborative system architecture that it means which is to execute with the federated logistic the framework, which is the major entities such as the local Internet of healthcare thing and the global parameter server. So for the collaborative, the procedures are the comply with the communication resource acquisition policy for the central model aggregation and the averaging. For this is three primary, the option the whether to operate in cloud, edge or hybrid. So in order to acquire the adaptive decision for the controller, the attendance of the IT healthcare thing, the environment. So the difference of the features in the label between the participant and the service are enhanced by the multi-service container to select with the which one is the IT healthcare thing the participant require for the service, and the consist of the computation to perform and capability of security communication run. And one more thing, it will be to security of the highly quality of data. They consider of the edge computing or cloud edge to perform in our model to apply on prediction. And the second is the third is the global computation. For the global computation, we will select on the IT healthcare thing node that is from the distributed model, such as the local data and the participant, the time slot, and it is also considers execution on the device that will be consider on the time slot into the distributed cloud. And among of that, we will apply with the algorithm that designed with the loss optimization. And before we update the global prediction model to the parameter server, the local participant require the optimizing the model the parameters used with the loss function that are defined to predict our model, and it will be based on the model and parameter. And one more thing is the model of the transmission. After the determination of the complete of model with the optimal parameter or the possible of the loss, the selections of the IATs, the participant is mean is the IATs hierarchy. The participant within its defined iterations can be updated the model for the aggregation in the Federated Logistic Regression server to follow update the scheduling and the aggregation policy in the framework. And for the age of assist procedure, the system heterogeneities and the number of the directions around communication that are alleviated by the leveraging of the X server's capability to ensure for the each service level aggregator will be near through the local node. So the transmission procedure include with the handshake and the handshakes of the initializations for the client selection, the global model distribution, local predictions model, and the training and the parameter of the optimization scheduling for the model updated and the aggregation policy. So the final list of the global model aggregation, the use of the averages model will be distributed to the back of the client for the optimize toward the stratify of the key performance indicators such as the time mission critical real-time communication. So the aggregation of the process, the weight of the metric has been implemented as an influencing of the factor for the IoT, Internet of the high-casing client that is contribution more than high qualities of data to perform with the Federated Logistic Regression system. So for the contributions of the each client have a different weight plus of enhancing the aggregation the strategy. So we will emphasize emphasizing what the measures of to find the actual rate and balance the strategy the find the apply with the federated learning to try to predict and to adapt with the service type of the different type of the client that need to be considered in the in our specific scenarios, such as the communication, critical computation intensive or energy constraint. So we will go to the data collection and analysis. For the data collection and analysis, we use with the for the data set. In this study, we will use the 2018 annual data set version 2.01 of the current medical panel of the survey, which is jointly by the Korean Institute for Healthcare and Society Affairs and one more National Healthcare Insurance Service. So the predictions model in this work, we will consider the hyperparameter use case, which is the trigger, the features of the egg, sex, debate status, physical activity, smoking status, occupation, and education level. So before the data set of that we use to procedures of data that are now target and drop the from this number to this number that we will use with the logistic regression to define the essence of the coefficients. And as we can see in the figure, the table, there are many of the original feature, and among of these features we will they also describe with the definitions of the feature x1. So it is, and the coefficient represent to the consider with the hyperparameter the use case and that are determining the of the data set. So in here, to the figures 2 is it is the performance metric that execution time that determine the end-to-end time for the model reaching the metric that's comparison with the proposed and the convolutional federated logistic. So for the performance metric with execution delay determining that the star are stratified with 95%, and from the early training phase the proposed scheme that can be achieve model with the convert between in the 10 points per second, which is the first appearance in our round communication. So go through of our section. In this study, the Federated Logistic Regression is proposed to predict this is of the in obtain of the objective for the real-time and privacy, the preserving the aspect that converging with the federated paradigm and logistic regression to ensure inside of the softwareization and visualization to adapt with the resource placement and the offloading strategy. And one more thing, it is to ensure the privacy constraint and the real-time communication for the real-time prediction. And the actual rate of the model is the progressing round of the communication is highly stable and efficiency compared to the conventional federated approach. So today for my presentation is finished. Thank you for taking your time to listen to my presentation. If you have any questions, please drop a text to my Gmail. Thank you for today.